This is Pitchdeck Asia. We are in the Asia Tech podcast studio. My name is Graham Brown, joined by Paul Guillaumot. Did I get it right?
Yeah, very well.
Paul, welcome. Thanks for coming.
Thank you very much.
And we live, I know this is Asia Tech podcast. A lot of what crosses our table on a daily basis is technology. And often that technology is out there in the ether. So we see a lot of blockchain, for example. But today we're going to talk about touchy-feely stuff we can actually see, make and feel. We're going to talk about spare parts. And you got a bag of spare parts here with us today.
Is that the point? I want to differentiate myself by coming with actual physical stuff, you know what I mean?
Exactly. And if you're listening, if you're not watching this on the video, if you're listening on the podcast, if you just got audio, we'll have to describe what you're doing and what you're pulling out of the bag. Well, maybe we can start. Let's just pull something out of the bag. Can you produce from your bag of tricks one of your spare parts and tell me?
I'm going to give it to you, actually.
Do I have to guess it? It looks like, and I'm going to guess.
Yeah.
Right. It looks like something out of a washing machine.
Absolutely.
Am I right?
Yeah, you're
I'm
right.
not even an engineer. All right. So
it's actually a filter holder for a washing machine.
Oh, there you go. Everybody, that wasn't a setup. That was completely random. So
I took out one that's pretty much very nice, especially on the surface finish,
right.
and that's kind of stuff you just don't know whether it's really printing or not.
Right. Okay.
So
why this? Why do we need to see this? Why is this a part that needs to be printed?
Basically because manufacturers of home appliances like the Whirlpool, Midea, all these companies, they have so many parts to manage in inventory, in after sales, that basically they have stock out all the time. So when they have stock out, they are stuck and they are not able to deliver to their customers. So the interest of being able to 3D print is that we can 3D print on the spot straight away and locally, so that we can deliver the part much, much faster than conventional manufacturing process.
For the manufacturer or for the consumer?
For the manufacturers.
And so they can sell it to the consumer.
Absolutely.
So I had this problem recently. I bought a blender, for fruit juice, and the blender was about $40, and the top that sits on the blender, I don't know what that's called, but let's say it's the glass, but it's plastic, right?
Yep.
You put your juice in it and you blend it.
The cover.
That broke. But I went back to the manufacturer and I said, look, I need another part. And they didn't sell it on their website, but the actual part was about $30. And I just thought, well, I'll just go and buy a new blender. It just seems pointless. That seems to be a problem all over. There are websites that sell these parts, but they're very expensive, aren't they?
That's right, and especially the case for small appliances like this. But when you come to a dishwasher or fridge, you don't want to replace a $600 fridge because of a $30 part. So
exactly.
You have a bit more room to repair, and most of that are apart from dishwasher, fridge, or all the biggest appliances, because small appliances makes it much difficult to repair due to the economical constraint itself.
Yeah.
And I'm not really going to solve that. We are more solving the problems of every time you are calling the repairman and the guy is telling me, I need to order the parts, but I don't have it, and I'm going to wait for 3 weeks or 3 months even to get it, or simply, sorry, the part is phased out, I just cannot repair, you have to rebuy another one. Yeah. Which happens a lot, actually. It's like working with the OEMs themselves, it's about 10% of the parts that are ordered by customers, they are not able to fulfill the demand straight away. Because the parts are not at the right place at the right time, whatever the reason is. It's a reason of obsolescence or shortages or stock out due to supply chain issues or plenty of things that happens that makes it just not available. So that's the kind of stuff we are solving here.
And if you can't get a part, you're screwed, right? There's no second option, is it? It's not like it's a $600
that's one
dishwasher.
Of the problem.
Exactly. So what have you got in your bag? What are commonly requested parts?
Are very common being knobs. Stupid
knobs.
As it looks. But they have so many of them.
So maybe you can reach. Maybe you can hold it up to the camera there. You can show us some of your knobs. Okay, let's have a look. So we got here. I'm showing this one up. I mean,
I got plenty.
But that seems something like a really basic thing, right? But if, for example, what was that from? That machine?
I don't know.
You don't know?
I really don't know.
It looks like it might be from...
usually it's a cooker or...
I think it's a slow cooker or something like that. It's something that might turn, like tick round, like on a timer.
So I got like a coupler. That would be a coupler from your mixer or blender. This kind of stuff.
That's what I needed. One of that fits
this one probably everyone will recognize. You have that in your washing machine.
Washing machine, yeah.
no one really knows how is it used for.
Yeah,
what is it used for? I really definitely don't know why.
Can
we
somebody
have this
tell
part.
me what number 1 and number 2 are? Which is the okay?
I don't know.
Which is the powder and which is the?
Don't ask me. I'm not designing the machines themselves.
Right. Okay.
Okay. Or some other stuff like, but that will be an old part that you have in old washing machines as well.
Yeah.
And that is basically when you're doing the programming stuff. That was the old manual programming parts.
If that breaks, you're screwed.
Yeah, because you're never gonna find that again. And if you're a manufacturer, usually you phase out these parts simply because your supplier were producing that with plastic injection, and the minimum order quantity to produce that is like I need to have 10,000 or 100,000 to make it economical, while they have demands between 50, 100, 200 per year eventually, and on very, very old part like this, even less than that.
Yeah. So, I mean, treat me like I'm stupid because I'm not an engineer or understand how the manufacturing process works, but don't manufacturers have warehouses with like hundreds of thousands of parts in them?
Yeah.
So why do we then need this? What's the problem?
So again, the problem is when you are a manufacturer or spare part manager at a manufacturer, you are doing trade-off between having a very, very huge inventory. Normally, the one I mentioned, like Whirlpool, they have $100 million value of inventory, US.
Yeah.
And if they want to be able to deliver everything everywhere, they have to triple or multiply by 4 or 5 this level of inventory, which costs them a lot of money.
Right.
Because it means that's $500 million that are just stuck and doing nothing.
Yeah.
And that's a cost of money.
And can it ever make it profitable? Can it ever be a profitable business for a manufacturer?
Yes, but most of the time it's not.
Right. So they've got one guy in a warehouse and he's serving the world.
Yeah, exactly. So either they have very, very huge cost of inventory, either they have low service level.
Yeah.
And they just cannot manage to have both.
Yeah.
So we basically solve the problem for especially what we call long tail. So basically when you are in after sales, you have like 10% of the parts that will break a lot, and that they fulfill very well. And they have inventory that is not sleeping, what we call. Meaning that the parts are coming and getting out very often, so it does not cost them too much in inventory. But all the remainings, like the 90+% of them, are sold very, very few times per year. So, but they have to have volumes. They have to have inventory to be able to cover it. And when you have lower volumes, you have more variations over the demand over the year. So you don't predict as well, and because you don't predict well, you have shortages. And so. For them, really, we worked on 2 aspects. One is increasing the service level, and the other one is decreasing their cost of inventory. So ultimately, what we want to do is to take off all these 90% of the parts out from their warehouse.
Right.
So that we produce everything on demand, and it doesn't cost them any money.
Yeah, exactly. It must be a huge headache cost-wise for them.
Yeah.
In terms of maintaining this.
Actually, it's like something like 30% depreciation of the value of the inventory per year.
Right, and like you say, you can't predict it. Like I don't know if I'm going to sell these like blender parts because I have to keep 10,000 of them, and then suddenly that blender goes out of production.
Yeah,
you don't know how many people around the world still have those parts or need them. Right. Okay, let's talk about spare parts 3D.
Yeah,
that's what we're here to talk about. I've got your pitch deck, so we can jump back in. We won't go through the whole pitch step, but maybe we can start by looking at the size of the market. You've already kind of identified. How big is this market?
So actually, we've been discussing home appliance,
right?
I'm really focusing at the home appliance market at the moment. But at the same time, we are opening on some other markets, which are more related to Singapore as well. The home appliance market itself for the spare parts is about $9 billion. Altogether, and what we know we can do right now is about 5% of that, knowing that the day we start really to work on the long tail, so on to digitalizing their entire warehouse, we are talking about 30% of that.
Right.
So this is in itself it's pretty big, knowing that we have kind of right now what we are doing for all the obsolescence, supply shortages, problematics, also the service level, the problem that they don't have the part at the right time. We can afford to have parts that are much more costly than conventional manufacturing. When it comes to the next phase, so basically the digitalization of the inventory, we have to be very, very close to the cost of original manufacturing, which we are not there yet in terms of 3D printing production. So So right now we are evaluating that as a niche of a few hundred millions, like 400 million, something like this. The interesting thing is that you have the same problematics in every physical product. So whether you are doing a car, a boat, an aircraft, an industrial machine, everything has spares, and it's always a headache for the manufacturers to use to get the spares. So we are already working with some companies also in the maritime market.
All right, well, we've got some of your case studies. We'll flash them up in a minute. We'll get to those. I mean, and you talked about automotive as well.
Yeah,
so, I
mean,
absolutely. Obviously the parts industry is huge.
But this one is a big topic.
Yeah. Well, we'll get there. It's
going to be a big fight.
Yeah, you've mentioned the pain points, which is great. We've looked at what the problem was, which is, just maintaining inventory is expensive, and it's not a great business, and it's not something they want to be doing. So they want you to be doing that for them in somehow, right? You've talked about what we're doing here. So we're manufacturing spare parts, 3D printing. What's the solution itself? What is it that you're doing here that's sort of different to what else is out there at the moment?
So basically, we are providing this as a service, as a solution. So on-demand spare parts as a solution.
Yeah.
And looking at the slides, we are basically doing this in 3 steps. One being helping the manufacturers start by analyzing their catalog of spare parts and getting a due diligence on what can be done and how much can I save. So basically, when you have 100,000 parts, you can come and ask me, okay, Paul, how much can you make this one for me?
Right.
Okay, how much can I buy it from you? I can give you a price, but that's not replicable to 10,000 or even 100,000 parts. So doing this due diligence on the entire catalog is something important, so that you know how much you can go, how far you can go on transferring your catalog to 3D, to digital, sorry. And then what's the value at stake, what's the opportunities that is behind that. That's what first phase, basically a consulting phase, and that's kind of my background actually. Second phase being doing the digital catalog itself. So you have to digitalize all that, meaning that we need to collect design data, so all the 2D drawings and the CAD models, the 3D format of the part. That's usually we get it quite easily with the manufacturers themselves, but then we need to do what we call technology transfer. So it has been produced by a technology, we need to do it with another technology, but it needs to be as good as the former one. So that's a technical assessment and a technical work and engineering work to be able to do this transfer of technology. And the last bit itself is being able to produce, and to produce pretty much everywhere. Because when you are Electrolux, you are selling in 120 countries in the world. And if you ask me what the first reason why you have shortages is customs. Because you don't get the part of the right in the right country because of customs.
Well, he gets lost.
He gets lost or blocked or whatever.
Thought, what is this thing coming through? It looks like it could be either a missile or something in a washing machine.
Or whatever.
Yeah.
And something is not well filled on the form or whatever. So we have to be able to produce locally so that we can answer these problematics in terms of shortages and so on. So that's the third bit what we provide as a service, is being the distributed manufacturing itself, and we do this through a network of suppliers that we qualify and for which we ensure the quality assurance, basically.
Right. I don't understand enough about 3D printing, so help me out here. Is it as simple as sending a design to somebody who's got a 3D printer and then they can reproduce that, so that, that would overcome the issue, in theory, with Electrolux, that you could have, if you had a printer in every country, you've dealt with the problem. Is that how it works?
So in principle, yes, and that's a bit the golden nugget of 3D printing. At the same time, it's like, for instance, the parts I've got here, you see that they all look a bit different, so on. They are based on 3 main different technologies. Actually, 3D printing is a bunch of different technologies. Right. You have 7 main big technologies that are completely different processes.
I don't know. So, okay. Because, I mean, I guess the materials is an important part of this, no? Or is it, you couldn't just like shove any plastic mold and, get the same kind of result, right? You need to know what kind of material goes into the plastic, So
that's where it comes to complexity. So you have different technologies, different materials, and different coupled technology and materials, because you don't process the same material with the same technology. You have a lot of limitations. So what you're saying is like, and a lot of people like, we heard a lot of 3D printing like 5-7 years back. Everyone was thinking, we're all going to do this desktop printer. We're going to have it at the house, and we're going to produce this stuff by ourselves.
Yeah.
In the end, it's very difficult to produce it. Second is there is a lot of limitation with this technology. And third is producing one part is simple. Producing one part to the technical specification of a manufacturer, meaning that it will withstand the temperature, the chemical resistance that it needs to withstand, or whatever kind of environment requirements that you have, is a complexity in itself.
Right.
So you have actually a lot of work to be able to do this engineering validation process, basically.
Right. So do you have your own printers?
No. Yes and no. So we have our own printers for everything that is related to R&D and part qualification, and then for the production we subcontract.
Right. Okay, gotcha. So you're not producing your hardware yourself for the mass production. You're only doing that for your own sort of research and due diligence,
yes,
like
absolutely.
you said. Okay, good. All right. So let's have a look, if we may. If we go back into the pitch deck, I want to forward to the part about yourselves and who you are. You've alluded to your background.
Yep.
You're French, obviously.
Yes. With
an accent like that. It couldn't not be anything but French. And you're from Toulouse, which is famous for, we were just talking about off air, for
Airbus.
So there's a lot of heritage of aerospace engineering, mechanical engineering in Toulouse.
Yep.
Your background before this, what were you doing?
So I'm a mechanical and industrial engineer. So basically everything related to designing components and producing components.
For any particular sector? Or?
No. Generalist, knowing that that's my study background, but I've never worked as an engineer, actually.
Right, okay.
I went straight away for strategy consulting. So I've been working for Oliver Wyman at first, and then spin-off of Oliver Wyman in Paris, working mainly in the industrial context. So a lot for Airbus, actually.
Yeah.
A lot for the French Railway Company as well. So basically doing not engineering work, but with companies that are very engineering savvy, reorganizations and due diligence and all the things that you do when you're a strategy consultant.
Yeah.
So I went quite away from engineering, but at the same time I was very keen on keeping in touch, and that's actually why I left consulting to come back to something that is more related to my background and my interests, because I'm quite passionate about that.
Do you consider yourself an engineer?
Yeah.
You are at heart?
Yeah.
With consulting experience?
Yeah.
Right. What does that do as compared to a sort of pure engineer who just makes stuff?
Being much more business focused.
Right.
Yeah. So basically always trying to know where the value comes from and what you're doing.
Right. Rather than just making it.
Exactly.
Because you want to make it, right?
Well, at the end, I think my personal background is really, it's really a mix of that. So pushing a lot. I'm very, very interesting. I was doing earlier technical due diligence on metallic parts for cranes.
Okay. Why did you choose that? Or was that something that chose you?
I had to do that.
Oh, okay, you had to do it, okay.
And but at the same time, always pushing a lot on supporting, especially the customers, to help them embrace the technology from a business perspective.
Yeah.
So that's why we do all this stuff related to the due diligence and the costing.
Right. And it also as well, I think it gives you a strength in being able to talk to engineers.
Yeah.
Like, you speak to a customer, they have a need. And then often if you go back to an engineer and you say, this is what the customer wants, if the wrong kind of engineer can be hard to work with, can't they? They can, I don't want to do that for the customer. But you have to speak a language that the engineer understands. And you can also understand whether the engineer is BS if they come back and say, well, we can't do that because of this. You understand
that's right. Also, it's not really my role. I've got a partner that basically is my clone. His name is Paul. He has done the same study background as I am. Another Paul. but he's a real engineer and he has worked on only as an engineer.
Let's have a look at the team then.
So I'm really the guy that is more being in touch with the customer and actually what brings my consulting background is the know-how to work with large B2B companies, sell in large B2B contexts, and talk and align with senior management level. to be able to solve what we to be able to sell what we do, because we have to sell quite high level in the organization what we are selling.
And you have to know how that sales process works and how to speak their language, literally at the large organization.
So I'm not so much the one doing the engineering talk and the one that say bullshit is the other pole.
Oh, I'm sure he's gonna love hearing that. All right, so are you all French as a team? Your board and your founding team?
Yeah. So actually, the founding team is Paul and myself.
Yeah.
The two Pauls. After that, I've got a team of engineers, and a lot of them from India, actually.
Okay. So are you based here in Singapore?
Yeah.
Okay. What is it, just out of interest, with French and engineering?
Nothing, and I thought when I was in France that we were recognized as good engineers, and coming in here, everyone is telling me, good engineers, German engineers.
Oh, okay.
Come on.
But there's a different type of engineer. I mean, Germans are famous for manufacturing, like cars and cookers and stuff like that. I think French are famous for more sort of infrastructure style engineering. It seems to be. That's the reputation.
Perhaps.
I just wondered if it's a certain mindset.
Honestly, what the thing with French engineers is like, we have a very weird education system in France. I don't know if you know about it, but it's like extremely elitist. And after high school, everyone goes for like 2 years of preparation. And then we all go to a contest with all the French students. And there is really two ways to get graduated with the very, very high level studies. Either you get an engineer degree, either you get a business degree. That's why you have so many people getting engineering degrees that will not necessarily be real engineers later on, but doing project management or whatever things.
So they end up working for the large engineering companies.
Exactly.
The engineering consultancies.
Yeah, but not only actually. A very, very wide range of people becoming very, very different.
Interesting. Okay.
It's just so you have if you're not a doctor or lawyer, everything has to go through this path. Either you become an engineer, so you have plenty of guys that becomes engineers and do something else afterwards.
Oh, well, thank you for sharing that. I didn't realize that was why, but I was always curious as to why engineers, came in numbers from France. So there you have it. Okay, let's go back into the pitch deck. So you looked a little bit at your team. Let's have a look at the timeline where we are in the business itself. So you started the business late 2015?
Yes. Absolutely.
So you're nearly 3 years old?
Yep.
Okay. You started the business Paul and Paul?
No, I actually started the business by myself.
By yourself?
Got Paul as an employee, and then
he came on as a co-founder, right? Okay. And how many people in the business now?
7.
7?
Yeah.
In the 2 co-founders and 5 engineers in India?
So 4 engineers, 1 business.
Yeah.
And at the moment, it's 1 Chinese, 3 Indians.
Right, okay. And they're based outside of Singapore?
No, all based in Singapore.
Based in Singapore.
And pretty much all with study background in Singapore.
Okay, right. Gotcha.
In some sense, I'm hiring locally. It's just that you don't have any mechanical engineers that are Singaporean coming out of Singapore University.
Yeah, exactly.
They are all either Indians, either Chinese. They are very good, by the way.
Yeah.
But it's just like I've tried hard to hire engineers, Singaporean engineers, but just not possible.
Yeah, I mean, again, it goes back to the education system, doesn't it? It produces a certain type of person, and there doesn't seem to be a strong heritage of engineers here by comparison to, let's say, India, and China, where there are millions, hundreds of millions.
But I can tell you, a master's degree from NUS or NTU in mechanical engineers, you are 40% Indian, 40% Chinese, and the rest is the rest of the world. Yeah. Pretty much from everywhere. And so you have maybe 5% of Singaporeans. Yeah. From what I've seen.
Exactly. So, I mean, you have been hiring here, right? Yeah. So, and it's a challenge. We'll talk about your hiring in a minute because it's an interesting challenge. I mean, I'm a startup founder as well. Yeah, I know. I face the challenges that you face, right? So, getting the people. I think not necessarily just the fact that they're engineers, but also that they want to work in a startup. That's another thing as well. So they need. Often engineers go for more safer type roles, right? Unless you're like in Silicon Valley, where you're an engineer, you walk into Facebook and so on, right? We'll talk about the team and the growth of that in a minute. I want to have a look at a case study, if we may, just so people understand, because we did talk about it earlier, and I'm interested in the automotive case study that you talked about. So if we can just sort of flick through the pitch deck on slide 22 here. Automotive aftermarket. All right. So you're talking about long tail. This is a key part of it, long tail, isn't it? Which is that, you may have like one part ordered by one customer. That's real long tail, isn't it? You just can't service that, in any effective way normally. What do you found with automotive? What kind of things are interesting in your market in terms of the spare parts?
I mean, in automotive, I'm just starting first, and especially working on Malaysia market because they have quite a huge auto sector. We find the same thing as with home appliance sector, and pretty much with the rest is long tail is really a huge problem, and it happens the same way everywhere. So it represents most of the of the part the manufacturer has. Automotive is actually very, very competitive because the volumes are quite large. So even for the long tails, the volumes are quite large, and they have quite common platform. Sorry, I would be a bit engineer. A very quite common platform in terms of manufacturing system. Meaning, when you produce a car, for instance, you have a big conglomerate. When you produce a car that is a BMW, you have a lot of commonalities on the part you are producing for key components with the Audi, with the Volkswagen and with the Seat, because they're all using the same manufacturing platform, and they have commonalized a lot of the engineering systems. So it's a bit more tricky. You have less, but you have still a lot of components and a lot of mixed, a lot of different parts, different components that have a hard time to service. It's good because usually, apart from Singapore, you keep the car for a while.
Yeah, well,
so
that's
the
a special
longest
case, right?
your equipment is you keep your equipment, the more difficult you get to find part at the end.
Right. So especially for vehicles which have passed warranty, in Singapore they get scrapped, right? In many cases, but I mean,
everywhere else in the world you use, you just keep them and use them.
Yeah, I know exactly. I mean, it's crazy, but anyway, that's something different. But like you mentioned up there, back on the pitch deck, they've got the that titanium wheel, right? Titanium turbo wheel.
Yeah.
3D printing versus traditional printing, just so we can understand. I'm going to read it off the pitch deck. Just correct me if I'm wrong here.
Yeah.
You've got here 3D printing of a titanium turbo wheel is 3 days, whereas traditional is 25 days.
Yeah. So basically, that's an example of a metal part that conventional manufacturing, it's casted. Or this one, it's written CNC, but usually the wheels like this is casted.
What's CNC mean? I don't know.
CNC, sorry.
Yeah, we're not engineers sitting around this table.
CNC means machining with a milling machine.
Okay.
And so casting is basically a foundry process.
Right, so they would actually take the...
You have to have a sand mold, and then you pour your metal and so on.
Okay. They just grind it down effectively until the shape.
That's machining. That's CNC, you grind it down. And so machining actually is quite fast, but usually it's a problem of getting the raw material, so the block itself.
Yeah.
And the block of aluminium is not something that you find
right, it's quite wasteful
at the corner,
as well,
at the corner of the street. Yeah, it's quite wasteful.
Yeah.
And so that's why it takes it takes quite some time. And same for if you were a cast steel. So actually the two other examples are similar. So it's more when you are going for the foundry process, you have first to do a first part that would be a model. Then you create your sand mold over it. So you put it in the sand mold, and you take off your part. You open your mold in two, you take off your part, and then you will cast your metal, which is really a long process to manage. So usually what we see is that there are a lot of issues related to the long lead time in production for metal part that come from casting. And yes, the good thing about 3D printing is it's pretty much in and out from the printer.
Right.
So you can shorten a lot.
Could you 3D print metal?
Yeah. So I don't have here, but
right. I know it sounds like a stupid question, but I just wondered.
No. That's a very good point. It's because most of the people think it's only plastics. Yeah. But you have you can print metal, and there are more and more applications.
Right.
But just and everyone always asking about. But is it good quality or how does it work? And always my answer is you don't know about it, but in GE engines, aircraft reactors, you have key components of the reactors that are 3D printed.
Right, so they must be good.
It has to be good.
Assuming that they must be good on the basis of the fact that they use them in aircraft, right?
Yeah.
Okay, good. And the cost-wise, the $400, was that for the 3D printed version?
Yes, that's for the.
And what would it compare to?
Pretty much
Traditional.
similar, a bit cheaper.
Okay.
It would be normally cheaper for the traditional
Right.
steel.
And the point here is about time and also inventory, isn't it?
Yes.
Because the guy who, like you say, they've got to do that crazy sand mold type process. You know, if he's going to just keep one of these,
so normally when you do sand mold, you're going to do 10 in a row. You don't just do one,
right?
And that's terrible.
And you have to store it somewhere.
And then you have to store it. So even though when you do 10, you will save on manpower and so on. You probably get the part for, instead of 400, you get for 150. But you're gonna keep the 9 others for how long? You don't know. But sometimes you just end up scrapping the
or they could all go next
so,
week. You don't know exactly.
You don't really know.
It's random.
Yeah.
Very interesting. And so obviously all of this costs money. You're raising funds at the moment.
Yeah.
Okay. So tell us a little bit about where you are in terms of. We'll go back to your journey here as a business.
Yeah, to the timeline. Yeah.
Yeah. If we can have a look at the timeline, if we flick that back up. That's up here on page 3. How have you funded it up until now, and then what are you doing from now on?
So I started late 2015. I actually started to get a team with Paul coming in beginning 2016, and got a first funding by myself. Until
by
June.
yourself means like friends and family?
No, I put myself.
Oh, your own. Okay, yeah.
My own money.
You are the friends and family.
Yeah, exactly. Till that lasts for about 6 months, and I raised a seed round mid 2016 for 200k euro. Everything is in euro.
So it's from French investors,
for, European investors a lot, and then later it came quite some Asian investors as well lately. So that was till that was basically mid 2016, and I that was the first part of the seed, and I actually that was my seed round that I kept small because basically at that time honestly we didn't really know what was our business case. We didn't really know what was our how we're gonna make money out of it. Even though in principle is clear, but seriously I didn't know how to sell, what to sell, and to whom, and so. It was a bit difficult, and so we started to bridge, to create a kind of bridge round mid 2017 that I got running since then. So I keep it on a rolling basis, and I got another 200k euros since mid 2017 till now, and actually still running this round, but I'm gonna close it in November this year actually. As I'm going through a crowdfunding process.
Crowdfunding?
Yes.
Is it equity crowdfunding?
Equity crowdfunding process.
What platform are you using for that?
So not Singaporean platform, but an English platform called Cedars.
Right, yeah, I know.
Which is one of, was a well-known one.
Yeah.
And so I'm going to run this campaign both in England, France, and Singapore as well with for the networks that I've got. And
but they can't invest in Singapore. They have to invest
it would be in France. Yeah,
right.
It would be in France. Also, actually, I still have an entity in Singapore, and eventually I can get some investors to come on board in Singapore. They won't care.
Right. Yeah. Sure.
As long as I've got an entity in Europe to run the process, I still can get investors, and I already did get some investors that will be part of this round that are in Singapore, that invested in Singapore. So it's quite flexible in a sense.
So what are you raising on the platform?
So about 200k.
You're right.
Yeah.
Okay. And interesting about why did you choose equity crowdfunding as opposed to going to angels or early stage in VCs?
To me, it's exactly the same as going for angels. It's just creating a pace to close a round.
Yeah.
Just because we are two founders. One is operational. I'm doing the business development. Honestly, I don't spend much time in funding, which I from experience, I've seen a lot of my friends funding companies. It's like you have to spend at least 50% of your time. If not more, to fund, and which is most of the time not possible. I think I've spent maybe 10% of my time funding the company since the beginning, and right now I'm saying, okay, I need to just close around and stop this bridge for a while, and that's why I'm just creating to me a timeline to close around, and creating a momentum through the funding process. That's really mainly the topic. I actually will bring most of the investors coming in by my network and by all the angels that I know, but it will be just getting a pace and getting
it's the process,
a process
isn't it?
itself.
Yeah. Okay.
That's what I'm interested in.
Do you think that works well for, physical goods and sort of engineering type projects in equity crowdfunding? It seems to be there's a lot more of those. And I wonder what the issue, why that is sort of attractive to them.
So I've looked at that like last year, and I was seeing a lot of B2C products, and mostly B2C products. And lately, like over the last 6 months, I've seen that there have been more and more B2B products or B2B2C eventually. But mainly, I find that the interest onto not necessarily some goods that you get on your hand at the end of the process is coming because of people are looking at investing, not necessarily getting a crowdfunding campaign. And so I find it interesting. I've done a little bit of due diligence over the last 2 months to prepare that, and find that basically you still have to have a product that is giving people a vision of something that is impactful for them. So basically, to me, I guess, and that's why I mean, most of my thing around my investment is around home appliance, because basically that's the business we know, the business we want to scale. Even though we are doing other kind of industry at the moment, but it's really because everyone recognizes himself.
Yeah, we all use
everyone has a problem with the remote control with the the stuff that is supposed to close the batteries.
It falls
that
off
is
the
missing,
back.
and you put a tape or whatever. That's everyone has a story like this, so you relate to it. I think that's one of the key important thing when you are going for crowdfunding.
Yeah. That makes a lot of sense. Okay.
Yeah, and the other takeaway I've got,
please share,
is basically consider that the platform itself is not bringing you investment. It's bringing you a methodology to create a funnel for your network, your company network, to bring in investors.
Yeah.
So if you don't have the investors in your network,
right,
you have less chance to succeed. The guy will top up with maybe 20. I'll say my evaluation is 20 to 40% or 50% of the investment, not more.
Right. Is that because obviously there are people you might think, for example, Seed Us or any of those other platforms have these ready-made investors just waiting to pounce on opportunities. That may be at the beginning, but that's now gone away. What you're saying is you have to use it for your own network. So is that because it gives them an easier entry point? They can come in at a lower level or a smaller level. Then
I think so.
Okay.
I think so. That's one of the reasons. Second reason is again the momentum of the fundraising. Fundraising is a sales process. You have to to put people
it's a movement.
into.
They're missing out. The train's leaving the station.
Exactly.
Okay.
And when you're doing that on all the time and just you don't have this closing date or this final date on which you need to put or not.
Yeah. That makes sense. Okay, good. And lastly, about your team. Now, you're a startup founder, and I've stopped asking startup founders coming here, are you recruiting? Because every single startup is recruiting. Okay. It's just an ongoing process. So I'm not going to ask you. I mean, you're obviously raising funds. You want to get new talent on in the future. What kind of people would you be interested in being part of your team? Are you looking for particular skills? Are you looking for, geographies, backgrounds? What's interesting to you?
Pretty much the next profiles I'm gonna hire will be business development, but in Europe,
right?
Not in Singapore, and a developer full time as well.
Right. And what do they have to bring to the table? Is it sort of 10 years of selling to white goods manufacturers, or?
Not necessarily. I think a lot of motivation is the first factor.
Yeah.
I think everyone is saying it. You don't really get people based on their skills, but mostly on their on
attitude.
Yeah.
What are you looking for? Because if I was pitching to you, I'm going to work all these hours and I'm an entrepreneur. But is there something that tells you that person is the right fit for spare parts?
I don't know. I think I've got kind of a bias because I've hired a lot of people for strategy consultancy.
Yeah.
I've made a lot of interviews and for this kind of roles, and I know what I'm looking for in terms of attitudes, and I think it's what I'm looking for is basically it's also how the people are. What is the thinking process of the people and the way they behave when they interact, which are not, you know what I mean. It's not. It's extremely fit based. It's not. Yeah. It's not really about the competence itself.
Yeah.
So what is that? I need to have people that are extremely structured in the way they think and the way they organize things. Simply because I delegate a lot and I don't follow up on what I delegate. You
want to know it's being looked after.
Exactly. So I want to have only people that are extremely autonomous, and means that it doesn't mean that they want to work alone. It means that I throw at them 10 stuff at the same time, and they will juggle with it, and they will come back with an organized manner to attack the agenda.
Right. Yeah.
So that's one key thing for me, and it's really depending on how I want to manage people. And I don't want to be looking after my team. So. Yeah. That's really one of the things. Second is being, and that's again one of my bias, is being a super rational person. But that's again something that I'm looking for. But for instance, for a business developer, that will not be what I'm looking for.
Okay.
For a business developer, it will be someone that is a no shame. You know
right.
what I mean?
Not afraid of rejection.
Not afraid of rejection, and it's also not an introvert. Being really an extrovert, that's the kind of guy that just spend his time. In the thinking process, I differentiate introvert and extrovert being on the thinking process. Introvert, you think, then you exchange, and then you think again. An extrovert will be exchanging, thinking, and then exchanging again. And that's really what you need to be able to be at ease and connecting with a lot of people without overthinking everything. So that's, to me, the key attitude of a guy that will be selling, because he needs to be pleased to connect and pleased to talk to people, and of course very, very motivated, because that's a very tough job.
Yeah, you want them out of the office.
Yeah, exactly.
What are you doing in the office? You need to be out there knocking on the doors and going speaking to this manufacturer and so on.
But most of them, so what I've described is mostly for my team of engineers. But even the guy that is doing marketing communication, to me, it's a back office job, and being organized is mostly what will drive efficiency on the job.
Okay, good. Well, Paul, you've given up some secrets as to the kind of people you're looking for, which is great. I mean, because people listen to this, they know what you're looking for and whether or not they connect with you, and they can just get a feel for you as a man and the business itself and what you're trying to do and your mission, and that then either connects with them or it doesn't. And people will think that is the company that I want to work for. That's the man that I want to be, in the same team as. What would be the most effective way to reach out to you? Do you have a preferred channel?
Emails.
Yeah. I will put all the details in the show notes. There you go. Fantastic. Paul Guillaumot.
Yes.
It's been a pleasure sharing this journey with you. Spare Parts 3D. We'll put all the details in the show notes. We wish you all the best with your equity crowdfunding.
Thank you very much.
We'd love you to come back on in the future as well and give us a before and after.
Yeah.
So tell us where you are with after the raise, and what you learned from that crowdfunding process. What your business is going to evolve, right, as it has done. So we would love to get an update at some point.
Sure. I would be pleased to, yeah. I think it's always better to get the after.
Exactly.
See all the shit that happened in the process.
that is the entrepreneur's life.
That's exactly. much funnier.
We're guaranteed to have a lot of shit between now and the next time that we speak, but then that's what we signed up for, being entrepreneurs.
Definitely,
right? Yeah. Great. Paul Guillaumot, thank you so much.
Thanks a lot.